Alright, in this video we're going to look at two related rate questions. One having to do with a sphere and one having to do with a triangle. So, the snowball melts so its surface area decreases at a rate of 1 square centimeter per minute. Find the rate at which the diameter decreases. Here's what I'm going to do. Because most of our formulas have to do with radius, I'm actually going to solve this entire problem with radius. And then at the very end, I will talk about how I can relate this back to the diameter. Okay, so just so you know, I'm not doing this as a misprint, okay? All right, so first we draw our picture. Well, it's just a sphere. I'm gonna deal with the radius. Okay. Rate. Well, the only rate I know is that 1 square centimeter. That's the surface area. So change in surface area with respect to time. And I'm going to say that it's -1 because the surface area is decreasing. Okay. So that's the only rate I know. Now, what rate am I looking for? Well, again, as I said, I'm going to do this with radius, and then I will work the diameter at the end. Okay. Equation. Well, the equation that relates them I provided just here. The surface area of a sphere is 4 pi r squared. Okay. So as we do the derivative of surface area with respect to time is equal to 8 pi r dr dt. And again, we need to do that dr dt because we're not taking the derivative of r with respect to r, we're taking the derivative of r with respect to time. So now we substitute and solve. We've got -1 equals 8 pi times diameter was 10, so radius would be 5 dr dt. Okay, so now we could divide by that 40 pi. So dr dt is 40 pi. Now, knowing what the rate that the radius is changing at, all I would need to do to get the rate at which the diameter is changing is double it. Okay, so dt, if you want to think about diameter, doubling the -1/40th would give me over 40 pi would give me that. The units, well, it's a length now, so it'd be centimeters per minute. The other way you could do this, if you were kind of unsure of that relationship, is you could say that the diameter is equal to 2 times the radius. So the derivative of diameter with respect to time is equal to 2 dr dt, which is where we get that, that doubling. Okay? Next. Two cars start moving from the same point. One travels south at 60 miles per hour. The other travels west at 25. Okay, so let me draw my picture right here. We got west, south. We're looking for the distance at which they travel changes. Okay. So here's my picture. Now, the rates. Well, I know dx dt is 25 miles per hour. I suppose I should label it. I know dy dt is 60. And I didn't label the length. I would probably just say z because it's x, y, z. I'm looking for dz dt. Well, the only equation I have that models them all or puts them all together is Pythagorean theorem. Derivative Now, I don't know what x and y, or z are for that matter, so what I'm going to do, I'm just going to leave some parentheses here. I know dx dt is 25. Leave some parentheses for y. Dy dt is 60. I don't know what dz, I don't know z, I'm solving for dz dt. Well, how I am going to substitute in x and y here is, I know, like for x, that we were traveling 25 miles per hour, and we were doing it for 2 hours. So 25 miles per hour for 2 hours, that means x has a length of 50. For y, 2 times 60, so 60 miles an hour for 2 hours is 120. And then I could use Pythagorean theorem, and I could get what z is. So now I could divide both sides by 2 times 130, and I get dz dt is 65 miles per hour. One thing I just want to caution you on at the end here is that a lot of times when people will look at this, they'll say that dy dt should be negative because the car is driving down. You know, if you think about like on a coordinate plane. Remember, we're not describing the movement right now in terms of a coordinate plane, we're describing it in terms of its size. And as as the car drives down, the length y is getting longer. The only way for it to become shorter is if the car was driving towards that point. So we were correct in saying that both rates were positive because both lengths, x and y, are getting longer.